Hello, everyone. Welcome to the October 2012 Professor Messer Network Plus Study Group. This is a group that gets together once a month, and I take your questions and answer whatever's going on. We're getting into the fall. This is our October version. We've got frost on the pumpkin, hay in the barn. It's now getting a little cooler outside and around the northern hemisphere anyway. A little bit different for our folks in the southern part. But one of the things that we'll do every month is sit down and go through your questions. I have some questions where I have prepared some formal answers to those questions. I think I want to step through and give you a little more information than you might normally get when you're watching my videos, which are so concise. But I think what I want to be able to do is provide you with a way to see a little bit more than that, a way to get some feel for some insight into these things that we are learning. Some of this will be on the Network Plus exam. The bulk of what we'll talk about will certainly be there. And if I tend to stray off of those particular subjects, I try to fill you in on what's there. I am watching the chat room on both. Today we're using Ustream as our streaming live view. I'm trying different streams all the time. That's the one we're trying today. If you aren't quite certain how to get to that chat, you can always go to professormesser.com/live. And for those of you watching live, I'm watching the Ustream chat, and I am watching a chat room that is on our live 24/7 chat at the bottom of every page at professormesser.com. There's a live Network Plus study group there. Make sure you go into that. I am watching both of those to try to get a feel for what's going on with those. And I appreciate everyone who has watched these in the past, who watches our videos day to day. I really appreciate it. I would not be able to keep these videos going. I would not be able to do these live study groups without the support of everybody watching those videos. There are some people that are also sending me messages that say, I'm going to be off the net. I won't be able to connect live to watch those free videos. So I do offer some for sale as well, that you could take them offline. If you'd like to learn more about that, you can find it at professormesser.com/download-network plus. And you'll also see links, of course, at the top of Professor Messer. You'll see links on the video page index itself, so you'll be able to find those wherever you might happen to go. Now, if you already have a Network Plus certification and you're trying to get continuing education credits, this also counts towards those. You can get up to, as you can see here, let's make this a little bit bigger. You can see up to 6 CEUs for Network Plus. You've got quite a few options there that you can get for watching a event, seminar, workshop, podcast / webinar, or conference. That's not enough to completely fill every possible continuing education credit that you may have, but it's a good chunk, and it's some very, very easy ones to have there. So something to think about when you're planning out where to go next with the things that you're doing. What I do for this study group is I put out a notice about a week before, and I tell everybody, hey, I'm having a study group. Send me your questions. I have you register so that I can send you an email blast. And then once this study group is over, I delete the list and we start fresh next week. But I have all of the questions that you've sent me, and you've sent me a lot of questions. Some of them, most of them, pertain to Network Plus. Some of them not necessarily about Network Plus. So we won't be covering those in this particular study group. But for those that are A+ questions, I hold those off. I stick them over in my A+ list. So I've got quite a list of questions to go through. I'll try to get through as many today as we possibly can, because there are quite a few there. So we're going to see if we can jump into our exam content and see what's going on with some of those things. The first question I got is one that we talked about probably about 5 months ago, almost 6 months ago now. But it's a question that tends to come up over and over again. And interestingly enough, it comes up a lot in real world use. And I thought it would be useful to go back through it and maybe stop and look at it perhaps from some different angles this time. The question came from RM, and it was, what does a switch use to make its forwarding decision? And that's an interesting question, because this ties into a lot of other questions I got during the month. In fact, I could have put up another question that says, why would I ever need to know the OSI model? Does it really apply for real world use? And what a great question, because that is a question I tend to run into quite a bit, is I'm learning this OSI model. I have no idea why this OSI model is an issue. And I think that's where we should focus our efforts in trying to understand more about what we're getting during that time frame. Now, I'm noticing for those of you in the chat room that are saying, hey, it's lagging a bit. And in fact, I'm seeing that on my side as well. We're going to see that flash queue just queued up a little bit. It got a little bit better. So I'm hoping that we won't have to stop this and restart it. So you should be able to see it. Yes, indeed, it did smooth out. Keep me on my toes in the chat room, everybody, because I'm not always looking. I have a little dial on my screen that tells me when it gets really, really, really laggy, when I hit that limit that's in my queue that I have. And this time the queue went away. So we're going to keep watching that. So please keep your eye on it and keep me honest with those pieces. I don't want to start talking and explaining something and you've missed it before the flash queue went away again. So I'll keep my eye on it as well. So the question about OSI model is a good one, because the OSI model is if you've never seen anything dealing with networking before, it is a very, very odd thing to have to deal with. It is 7 layers of something, and it's all theoretical for the most part. We try to put physical world things into it so that us human beings can understand what we're dealing with, but it's just a guide. It's just a model. Not everything in networking, not everything in technology fits nicely into the OSI model. It's something there to help us understand and help us associate things that we're seeing with other people. And so this question I thought was a good one because it plays right to the OSI model and how I would describe this to somebody. If you've gone through my videos, you know that I talk about hubs and switches and routers. And when I talk about hubs, switches, and routers, I stick them into an OSI layer. And that's because questions like this, how does a switch make its forwarding decision, is associated directly with the OSI layer in which that device lives. So let's look, for example, let's start with hubs. A hub, you don't see them around much anymore. In fact, if you find a hub, it's something that's a very old piece of machinery these days. They don't manufacture hubs anymore. The way the hub works is you send traffic into one port, and that hub sends that traffic out every other port in the device. So if you have a 24-port hub, you put data into one of those ports, that data is blasted out all 23 of those other ports in that hub. Doesn't seem very efficient, does it? Well, it's not. And at the time, that's all we had with half duplex Ethernet. You plugged into a hub and everybody heard everything on the network. If you sent it, everybody heard it, whether it was destined for their device or not. So that's a bit of a challenge, of course, and we're dealing with hubs. I sometimes refer to them as multi-port repeaters because we're simply plugging in one port and we're blasting it out every other port in that particular hub. Well, not very efficient. And we think of those hubs as really working at layer 1. There's no rhyme or reason to it. You put data in, it just blasts it out. It's a repeater. It's signal. We're just sending signal out multiple ports at one time. Very, very simple in the way that operates. There's no lookups as to where the traffic is going. There's no intelligence to allow or disallow it to go to a particular port. That was really the only thing we had back in the half duplex days. There wasn't a smarter way to do it. And it's very difficult to explain sometimes when the industry makes a major leap in technology. But that major leap in technology occurred when switches were introduced. Switching was, when it was released, something completely new and completely different that allowed us some amazing capabilities. Switching was much more intelligent. The device that we were plugging into wasn't a dumb hub that would simply send traffic everywhere. The switch knew exactly who was plugged into it. It knew the MAC address of every device that was plugged into it. If you were plugging in from a router, we'd see the MAC address from the router. If you were plugging in from a workstation, we'd see the MAC address from a workstation. If you were plugging in from another switch, we would see all of the MAC addresses that were coming from that other switch and plugging into that port. So some ports on a switch have many, many MAC addresses associated with them. And the switches, when they receive traffic, would make a decision about where traffic went based on the MAC address. Layer 2. Switches are layer 2 devices. MAC addresses are layer 2. And that's why when I'm describing switches, you always hear me talk about switches as being layer 2, because that's how they think. There's no blasting of data everywhere unless the switch just simply doesn't know that MAC address. And there's a lot of interesting scenarios you can get into there. But for the most part, when you plug into a switch and you want to talk to the router, your traffic is directed directly to your router. It doesn't blast out to everybody else who's connected to that device. Very, very intelligent in the way that it operates. Very, very useful in the way that it operates. This is one of the things you get into with switching, and suddenly two devices can be talking to each other on the switch. Another two devices can be talking to each other on the switch, and yet neither one of those devices even knows the other is transmitting data. We're not having to wait for data. We're not having collisions. We can all be full duplex directly into the device. What an amazing jump in technology. Now, to be able to do this, the switch has got to do a lot of work. Behind the scenes, the switch has a huge table of MAC addresses. It builds it. As it sees data coming in, it makes a note of it. And as people are sending traffic back and forth, it tries to categorize and fill in every single MAC address that it ever sees coming through the switch. And then if it sees traffic destined for a MAC address, it looks through its list and says, oh, well, you're on port number 4. Let me send that traffic to port number 4. Oh, here's another MAC address destination coming in. That's on port number 7. Let me send it directly to port number 7. And in the cases of enterprise switches, these can be massive lists, enormous lists. In fact, it's one of the things you look at when you're trying to buy a switch is you look at the capacity of that table. You look at the capacity of that MAC layer forwarding table that's inside of that device. In a workgroup switch, you may be able to keep 1,000 addresses. In a core switch that's in the core of a network that has hundreds and hundreds of interfaces on it, it may support thousands and thousands and thousands of MAC addresses inside of it. Very, very useful. So when you're plugging to a switch, we don't even think about it. It's all automatic. It's all behind the scenes. It becomes a little bit interesting whenever you start sending data into the switch. It magically knows where to send it. And it magically knows where to send it because it's sending it based on the MAC address. And we also, when we're describing hubs and switches and routers, we put hubs in OSI layer 1. We put switches in OSI layer 2. We put routers in OSI layer 3. So as an addition to this particular question, just remember that routers don't make their decisions based on MAC addresses. Routers could care less about the MAC address. The routers are most focused on the IP address, source, and destination that's going through the router. And so it's looking at the layer 3 information. An IP address is a layer 3 address. It's OSI layer 3. It's a router. And that's why we always tend to make those delineations between hubs and switches and routers, because we want to delineate very clearly OSI layer 1, OSI layer 2, and OSI layer 3. So that was a very good question that leads us into the next question that I got from RH, which was, how do routing tables work? This was another one that we talked about a little bit about 6 months ago, but I thought, again, it would be good to look at that list and see, where are we using routing tables? How are they used? And I mention this specifically because the routing tables are inside all of the devices that are on our network. When we think about routing tables, though, we most often think about routers. It's in the name. But indeed, your device that you're using right now, if you're communicating via TCP/IP and via many other routing type of many different protocols, they all have some way to route that traffic in and out of your computer. Now, your computer is probably the easiest routing table you can think of, because most computers have one interface card on there. And the routing table probably says, if you're not talking to yourself, if you're not talking to a loopback connection, just go out this port here. Routing tables are specifically designed to grab data that's coming in, figure out where it's going, and send it on its way. The routing tables inside of routers, of course, are much more complex. Routing tables inside of routers have many, many interfaces inside of them. They have 3, 4, 5, in some cases more interfaces. And when a packet comes in one interface, it really has to stop for a moment, make a determination of where it goes from here. And it makes that determination based on the routing table. Let's go through an example of this that might make it a little bit clearer. And I showed this example, and I think this is one of those instances where people say, is this really necessary to know this data? Is it really important that we step through all of these pieces? It's interesting to me because on a daily basis, I'm dealing with network professionals, I'm dealing with security professionals, I'm dealing with people in charge of infrastructures, in charge of data centers that have very complex routing environments. And it's interesting how many times, especially when we are adding a new device to the network or we're trying to troubleshoot a flow of traffic, we all have to take a step back and say, you know what? Let's go look at every device along the path and examine the routing tables of every single device. You will be surprised how much you end up looking at routing tables when you're trying to determine where traffic is going, or perhaps more importantly, why the traffic isn't getting to the final destination. So what I did was take my network here that I have at Messer Studios, and I built out what my network looks like. I have a pretty odd network. I have this network, well, it's not so odd. It actually is very common to things you might see somewhere else. But I have a lab network that's connecting these devices. My lab network is 192.168.1.0. It has a 24-bit subnet mask. I also have what I call my production network. That's the network that I'm on right now, that you're seeing this machine broadcasting this data to the net, and its network is 10.1.10.0, and it is using a 24-bit subnet mask. So I have a couple of networks here. Another thing that I also have is a link out, obviously, to the internet, and I've put in here an IP address. This isn't the real IP address I'm using to get to the internet. It's actually the IP address of professormesser.com, but it is one that gives you an idea of an external address that's out there. So if you're trying to figure out, if you're on a workstation on this 192.168.1.0 and you're sending traffic, or you're hoping you're trying to send traffic to the internet and it's not getting there, or maybe it is getting there, you want to be able to track the path that it is going. In my network, it's very simple. It's a couple of routers and you're out. In enterprise networks, traffic may take multiple paths to get out to the internet, and it may come back a completely different path. And this greatly complicates the troubleshooting process. But most of the time, you want that kind of redundancy. Traffic goes out one way, traffic comes in a completely different way. We call that an asymmetric route. Normally, we have a symmetric route like I have here. When traffic goes out one way, it comes in exactly the same way. It's symmetric. But when traffic leaves one way and it follows a different path to get back to me, it's asymmetric. Imagine troubleshooting that. Imagine troubleshooting traffic going out one way, and then we've got to use a completely different method to troubleshoot a completely different set of routing tables to be able to do that. That's one of those challenges you get into with routing tables and dealing with them, but let's look at them. Let's look at a routing table on this device. So if I look at this workstation has really one interface on it. It's plugged in, and that interface is 192.168.1.22. When you deal with routing tables, you can see there's a destination address of 0.0.0.0. This is very common to see in routing tables. We do that because that's a route to everywhere. That is what we call a default route, which means if it's not in the routing table, send it to where this destination is. This makes it easy to configure your routing table, obviously, because you don't want to have to put in every single possible subnet that you could ever possibly go to. Instead, you just have a catch-all that says, if it's not in my list, just to send it this direction, which means if you're sending it anywhere that's not in this routing table, send it to a gateway of 192.168.1.1 and send it out interface 192.168.1.22. So that way, if I'm sending data to 8.8.8.8, it's not listed as any of these destinations in my routing tables. At 8.8.8.8, nope, that's 127.0.0.1. That's my loop back. And then there is a network interface of 192.168.1.0. I'm not sending it to that. 8.8.8.8 is not on that subnet. 192.168.1.22 is not on that subnet. That's me. And 192.168.1.255 is the broadcast address for that subnet. That's certainly not here. That's 8.8.8 is not there either. So it all defaults back to the destination route, 0.0.0.0. So if I was pinging 8.8.8.8, I know that my machine will look at the routing table and say, oh, 8.8.8.8, I need to send this to 192.168.1.1, and I need to send it out interface 192.168.1.22. At the most basic level, that's it. That's a routing table. You'll have to now go to every device along the path to see if it's following the right path. But the same process occurs every time you stop. Just because this routing table is right doesn't mean that the next router upstream has the correct information inside of it. So in fact, let's look at the next router upstream. Let's go look at that one. Let's change our focus to this router right here, which has two interfaces inside of it. And I send into this interface, it's receiving a packet that's going to that Google DNS, which is 8.8.8.8. It receives the packet and says, okay, let me look through my table here. I have a 10. network I'm plugged into. I have a 192 network that I'm plugged into. I don't see 8.8.8.8 anywhere in my named list of IP address subnets or devices. So everything's going to default to destination 0.0.0.0. Now on this device, there's 2 ports. So we've configured the router inside of this device to say, if you get anything that you don't know about and you want to default it, go to 10.1.10.1. And to get there, you're going to want to send that packet out 10.1.10.14. Well, that makes sense, because if you look at this router, 10.1.10.1 is the next router upstream. It's the next hop going upstream, and it's going out the interface that is directly connected to that router. If we had misconfigured our routing table and that said 0.0.0.0, you should go to 192.168 1.1 out interface or 1.22 and go out interface 10.1.10.1, it would simply shoot right back to my workstation. And when my workstation received it, it would look at it and go, well, no, you got to go to 8.8. You go back out. And this router right here would say, no, back to you. And it would simply ping pong back and forth over and over and over and over again. Can you imagine? This happens a lot when you're misconfiguring devices on a network. It happens, maybe not a lot, but more often than you might think. You're putting a new device into the network. You haven't thought out the routing tables. You think you had it right. And as it turns out, the packet goes back and forth and back and forth and back and forth. Now, fortunately, in IP and TCP IP, there's something inside of the packet called a time to live. And I know it has the name time to live, TTL, but it's not really referring to a clock, not referring to a number of seconds or minutes or hours. It's referring to the number of times that it can hop through a router. Every time a packet hops through a router, the router takes the time to live field and decrements it by 1, decreases that number by 1. So if the time to live is 255, by the time it gets to this router right here and sent back, it's 254, and then 253, 252, 251, 250. So it cycles back and forth about 255 times, if that's what the time to live happens to be. When it hits 0, the router drops it, because it simply assumes at that point you're looping around and you've done this 255 times. You're obviously a little messed up in your directions. And so I'll loop it around 255 times, then I'm dropping it. Otherwise, it would just loop forever. It's interesting because in a switching world, when you create a loop, there's no time to live mechanism in layer 2. If you loop to switch, that thing will loop around forever. It'll break the switch ultimately, because you'll send so much traffic that ultimately starts looping. That's why we have spanning tree. That's a completely different study group right there. Let's go back to our routing table. So we've now looked at this and it says, yes, you're going to 8.8.8.8. I'm going to send you out that direction. Now, if you're going to anything that's on the 192.168 1.0 network, this routing table says, oh, wait, you need to go back out 192.168 1.1, sends it out a completely different direction. Look how important that routing table is. If you mess up anything in that routing table, it's not going to be able to go to the right direction. If you are setting up a routing table, a route, and you have multiple routers, and very often in these large environments, you have many routers between point A and point B, you have to go to every single router and confirm that the route is correct. Now, here's an interesting thing. What if you sent in a packet to this router, it was going to 8.8.8.8. What if this 0.0.0 network wasn't there? What if it wasn't in the routing table? What if this router had not been configured with a default route? The only thing it would know about was 10.1.10.0 and 192.168 1.0, those 2 subnets. That's the only 2 subnets that router knows about. If it receives a packet that is destined for 8.8.8.8, doesn't know where to send it. The router drops it on the floor. It's gone. That's it. Like, sorry, I don't know what to do with this. Throws it out. That's it. You have no idea what's going on. You sent the packet out and you're waiting. You're waiting for that response. Why am I not getting a response? You never will, because the router, the first router along the way, dropped it on the table. Dropped it on the floor. It never got anywhere. And that's really frustrating when you're trying to figure out, is the problem that 8.8.8.8 isn't there? Is the problem that my internet connection is down? This is where your troubleshooting skills kick in. You try to ping 8.8.8.8. It goes nowhere. The next thing you do is traceroute. And if you tracerouted, your traceroute will get as far as that router, this router at 10.1.10.14, get as far as that, and then it would stop. And at least you would know your Traceroute was telling you it didn't get any farther than this. So let's go into that router and configure it. Now in the chat room, people were asked, the question came up, so can you configure routing tables easily? Usually don't see that option if you have a router at home. Let's say you have a home router, a Netgear, a Linksys, a D-Link, one of those home-based routers. They don't tend to give you access to the routing table. But the only thing they really give you are some fields that can help you out. They're really designed to go one way. Go out to the internet, bring traffic back in, single-use boxes. If you were to look at your operating system, there is a command called route. There's a command called route in Windows, in Linux, and in Mac OS. And that route command allows you to view the routing table and to even modify the routing table. This can be very useful for troubleshooting, especially if you have multiple routers on your network, because you could tell your workstation, go out to 8.8.8, go that way. All right, that one works fine. Let me modify the routing table inside of my computer and now send it out the other way. Does it work that direction? Yes or no? So you can direct yourself exactly the ports inside of your device to go wherever you want it to go. Maybe some traffic should go out the wireless link. Maybe some traffic should go out the wired link. By modifying your routing tables, you can control this because that's how IP understands what direction to go. It becomes very, very, very useful to do that. And in enterprise routers, if you have a Cisco router, if you have a Juniper router, if you have any of those devices that are routers on your network, then the configuration in those is very clear about setting up the routing table. If you have a firewall that's running on layer 3, there's probably an entire page full of routes that you would have to configure. Another question in the chat room was this other column in here called the metric. Metric, in this particular case, I'm using a static route. I manually configured a lot of these. Actually, some of these were probably configured automatically, but I just made it simplified on my screen to see this. A metric is a cost of going through that route. And different routing mechanisms use different costs. They use metrics, or they use hops, or they use some other mechanism to determine the priority of the route. You will see this a lot if you have different types of links. If you looked at your Windows routing table, your Windows routing table is one that might show you. In fact, I may be able to pull one up here, except I don't think it's going to show us exactly what I'm looking for. But if you go into Windows, the command is route print. And I'm going to pull mine up so we can look at it. Let's see if I have, here we go. So I did a route print on my computer. And you can see, actually you can't see very well, the number of metrics that I have there. Let me make this a little bit, let's see if I make it wider, if that works. I don't know if it will be or not, but we're going to try. We're going to see what trouble I can get into. Does that work a little better? Does that move it over? It does not. I'm going to have to move it over. So let's do that. If I look at this configuration, I'll move this over just a bit. There we go. Now you can see those metrics a little better. Let me get rid of myself here. Let me get rid of myself here so you can see it. I've got to move these back over so you can see them. We're on the fly here. We're not messing around. We're modifying on the fly. So if we look at this list, I see network connections. Some metrics have a lower cost than others. And you can see some have a metric of 10, some of 266, and some of 306. That's the priority. That is definitely a priority that the machine can now configure to determine where it goes first. It's going to go through, in my particular case, with this particular routing mechanism, it goes through whichever cost is less. That's why we call them a cost. It's like spending money. I want to spend as little as possible. So it's going to go through the metric routes that are lowest first. Now, if that route isn't there, it goes to the next higher. So that makes it very, very easy to see which one comes first, which ones come second, which ones come third based on those metrics that we have here. That command, again, if you want to run that, I'll scroll up just a bit, route print in Windows. The different operating systems have different syntax when looking at route, but I think for the most part, especially with the Network Plus exam, most of this will be based on Windows troubleshooting tools. So your metrics might be different on yours. The metrics will also depend on how your system is configured, on how I've configured things inside of my system, on the operating system itself, and what you're running for your operating system. So you've got some options there. And lot of routes inside of my connection. I have a lot of different connections inside of this lab network. This is a virtual machine. So this is how to get out of my virtual machine and get onto the network and talk out to the internet. Those routes can be very, very powerful. And if you become very, very good at using these routes, you will find that it becomes much easier to work with and start manipulating things. I was with on a network recently, and we were trying to configure something on a physical wired connection. We were plugged in and we gave it a particular network number. And then we realized we needed a link out to the internet. We turned on the wireless link and it messed up the routes to the wired connection. So we went to the command line, we did a route add, and we added a specific route to our wired connection that wouldn't conflict with what was on the wireless side, and suddenly we were able to connect to both sides. So if you can become very, very good at understanding how to manipulate these wired networks and the wireless networks and determine where traffic goes using that route command, that can really save you a lot of time when you're trying to troubleshoot. Very, very useful in being able to do that. Okay, let's move off to the next question I have. I'm going to skip ahead just a bit. I have a lot more routing tables, and I have an entire video just on routing tables. You can step through every step along the way. In fact, in the video, I mess up one of the routes. I show you when a route is broken, and then we go through and figure out which one of these routes is broken, and we fix it to see if that resolves the issue that we're having. Here's another routing type related question. I thought this was a nice add-on to the question that was there before as well. In the routing table, I can see a network with a mask 255, 255, 255. What does this address mean? And in this case, if you are setting up a route and you say, I want to go to 8.8.8.8, and I want this 8.8.8.8 network that I'm setting up a routing to be a mask of 255, 255, 255, 255, that means I'm setting a route up for one device. If it's going to that specific IP, then send it this direction. If I wanted it to go to everything that was on the 8.0.0.0 network, then my mask would be 255.0.0.0. So if you see in your routing table, somebody has set up a route to a very specific IP with a mask that is what we call all ones, 255, 255, 255, 255. That's all ones in binary. If you see that, then that route goes just to that device. Those subnet masks are very, very useful. Now, in our routing table, we saw that. In fact, let's flip back to that routing table that was there. I'm going to go back to another list of routing tables here, and we'll see it. So in one of these, you saw a destination that was 10.1.10.255. Now, that with a /32, there's another one of .14 with a /32. 1014 with a /32, that's also all ones. 32 bits is the same as 255.255.255.255. And so whenever it sees this, that is the route just to get to that particular IP address. And to get there, in fact, that address is local to me, so it's not uncommon to see these. That local interface is local to me. The only time you would ever need to get to that IP is this particular destination. And if you want to get to 10.14, it's connected to me. Just go to this interface. It's right here. I'm locally connected to that. So generally, when you see an all ones and all 255s, a /32, it's talking about a single device, a single interface, a single machine, a host-specific interface. So keep that in mind as you start working with some of those. That becomes very, very useful to set up maybe route to this device there, a completely different device, you go this direction. You can really set up a very complex routing table that way. Maybe you want to, maybe you don't. Along those same lines, here's a question that interestingly comes up a lot. I don't think I've ever answered this on a study group, but I think it's worth making the point sometimes that we tend to confuse ourselves in IT. We tend to give things different names to mean the same thing. We tend to call things the same name, and they're two different things. And in the case of this, you've probably heard somebody say, I need to configure a gateway on this machine. On this device, I need to provide an IP address, a subnet mask, and a gateway. But on this device, I need to configure an IP address, a subnet mask, and a default gateway. Well, what's the difference? One's a gateway and one's a default gateway. Again, we're just confusing ourselves. They're exactly the same thing. So don't be confused sometimes when we start to use these terms where one's a gateway and one's a default gateway. In TCP/IP, in the configuration that we're talking about on everybody's machines, you would need an IP address, you would need a subnet mask, and if you want to communicate outside of your network, you would need a default gateway. An important consideration is that in IP, you have a default gateway, a default route, if you want to call it that. That default gateway, that's it. You can't add multiple gateways in your configuration. If you're a router, you might have that capability, but a workstation with an operating system has an IP address, has a subnet mask, has one gateway. And it's often called a default gateway. It's often called just a gateway. Sometimes it's called my default route, but don't be confused too much by that. We don't ever want to get in a situation where we're confusing ourselves with all these different words and dealing with that. So whether we're calling it a PC or a workstation or a laptop or a machine or a device, it's the same thing when we're dealing with gateways and default gateways. A good point in the chat room is that when we're configuring an IP address and a subnet mask and a default gateway, we get a prompt just for one. But if you've noticed, if you configure your DNS settings manually, normally we don't even do that. We just get our DNS settings directly from our DHCP server. But if you ever go in and look at that, you'll notice that the DNS configurations on your device very often give you two options. They give you a primary DNS and a secondary DNS, or they give you DNS1 and DNS2. And that's because you have options. We all recognize that the DNS is an extremely important part of what we do. I rarely type an IP address into my browser. I'm typing google.com. I'm typing microsoft.com, apple.com, redhat.com. I'm typing in the domain.com. I'm not typing in the IP address of Google. I don't know the IP address of google.com. I don't know the IP address of microsoft.com. I have no idea what those are. So when I type them into my browser, the browser looks at that list of DNSs and says, well, you have two here. I'm going to use the first one. And I'm going to go out to that DNS and ask, say, can you tell me the IP address for microsoft.com? What if that DNS server's down? That DNS server's not working for some reason. For the most part, for all intents and purposes, the internet is not functioning for me. I can't work anymore unless I can resolve a name to an IP address, and it's that DNS server that does that for me. That's why we have another blank there, because if I don't get a response from that DNS server, we have another option just under it, and maybe it's a second IP address. I didn't get a response from the first one. Let me go check the second one. Check to say, oh, the second one's up and running. There's some redundancy built in here. Gives me the answer. I can go to Microsoft.com. I can go to redhat.com. I can go to apple.com. I can get to these places I need to go. That's why there's an option for two of these DNSs. Notice that DNS has nothing to do with routing. The DNS's job is to tell me an IP address of a name that I give the DNS. So very, very useful to have that. That's why we see two options. And you'll find whether you're configuring a firewall, a router, a home system, a workstation, you almost always will have the option for a primary DNS and a secondary DNS. Now, the difference between gateway and default gateway, another point of clarification in the chat room is that the gateway is always a router, right? Is that where it's going? The gateway is always a router. Its job is to take all the data that's going out and to do something with it. So the only device that can really send traffic along its way at layer 3 is a router. So your gateway and your default gateway is the router that is on your local subnet. So if I have an IP address of 10.1.10.0/24, a lot like we saw before, maybe even I'll pull up a good example of that. So if I have a gateway, I'm here, let's say I'm this workstation, 192.168.1.22 on a subnet /24. That means all of the devices on this network would be 192.168.1.1 through 192.168.1.254. .0 is the network address, .255 is the broadcast. So I use everything in between. That means my default gateway has to be a number between 192.168.1.0, really 1.1, and between 192.168.1.254. Has to be one of those numbers in there. My default gateway has to be on my local subnet. Otherwise, I don't know where to send it. So keep that in mind as well. Your default gateway, your gateway that you're configuring an IP, has to be on your local subnet. In fact, most configuration utilities where you're putting in the IP address and you're putting in the subnet and you're putting in the default gateway and you click OK, it calculates that and determines if the number you put in for default gateway matches the IP address and subnet mask that you've provided. And if it doesn't, it tells you, wait a second, this won't work. You need to give me either the correct subnet mask, the correct IP address, or the correct default gateway. So pretty important for doing that. So in the chat room, somebody says, so the example on the screen wouldn't work, right? And you're right. If you look at this, notice that this is a bad routing table. The default route of 0.0.0.0. We're sending data into this router. Let's say we're going to 8.8.8.8. It says the gateway is going to be 74.208.221.1. And the interface I should go to get to that is 74.208.221.234. Now that may be right. On the internet, there may be a .1. But if the data is not getting there, you probably then want to call your ISP because you don't have control over what's in the internet, over what your ISP is doing. That's one of the nice things about this. You can call your ISP and they go, oh no, the actual default gateway for that network, 74.208.221.5. We don't have a 221.1. It's one of those things that you would find whenever you're working with that, where the different pieces are in dealing with routing tables. If you go through the video that we have online, I step through that step by step through every route along the way, and we go through the process of finding that particular bad gateway. Let's discuss another question I get quite a bit. And the question deals with this overwhelming, ubiquitous, very, very painful problem that you'll run into when somebody calls and says, hi, the network is slow. Now, it was working okay, but now it's slow. Can you fix that? Please get on that. Thanks so much. Good day. Wow. Where do you even start with that? Where do you even go with that? Now, we're going to approach it from a networking perspective. There are obviously many questions you would be asking your end user. What do you mean slow? What is slow to you? What application are you using that you see this slowness? Normally, how fast is it? How fast is it now? And then you go through the process of figuring out what subnet they're connected to and where they are and determining those pieces. But you tend to start simple and you work your way out. One of the most common things you would run into are determining, especially if this really is a slow network connection or not a slow network connection, is really determining what we're doing right now. Now I'm going to do, therefore, I'm going to run a ping. In fact, let's use that same number we're using before. I find that Google is a very good place to go for testing, at least a very good place to start, because generally Google is always there. Not always the case, but most of the time, Google is always there. The other piece that I find important is Google has a really good network. So you tend to get very good response times when you're working with Google, when you're sending information to Google. So let's look at an example of this. If I just do a simple ping command and I run ping.8.8.8, the thing that I'm looking at when I do this ping is I want to be able to see, of course, that I'm getting replies. And in this case, indeed, I am getting replies. And the size of the traffic that I'm sending, I'm just sending the smallest possible ping packet that I can send. The default, I can probably send smaller, but that's the default data that's in there. The time is what I'm interested in. 20 seconds. Took 20 seconds to get a response, 18 milliseconds, 20 milliseconds, to get a response, 18, 17, 16 milliseconds. There are 1,000 milliseconds in 1 second. That's a really good number. 20 is across, going all the way to Google and all the way back. If you start testing this and you see this, that's a pretty good number. So if somebody said, I'm having slowdowns when I communicate on the internet, you know that it's not everywhere on the internet. Now, another thing to keep in mind, specifically with these times in a ping, is they can be very, very inaccurate, especially if I'm communicating through a router or through a device that interprets ICMP, because ping uses the ICMP protocol. It sends an ICMP request, and I expect an ICMP response. But most devices aren't really interested in your ICMP. Nobody ever sends real data, production data, via ICMP. So it tends to put these enterprise devices tend to put ICMP at a lower priority, which means you may see a lot of variability in this. One time it's 20 milliseconds. The next response is 150 milliseconds. The next response is 500. Then it goes back to 20. That may not necessarily mean that you have a slowdown associated with your network. It may be that the traffic going through a device was set at a different priority, and that's what you're getting. But most of the time, that's a pretty good number. At least it gives you a feel for what you should be seeing. Now, the ping was good. Let's do another one except let's type it properly. Let's do another one just to give a feel, 16 milliseconds. And you can also, of course, set some command line parameters in here. 1941. The screen will update in just a moment. There we go, 41 milliseconds. So we got a little variability in there, but still 41 milliseconds, not so bad. Not so bad. Notice the time to live. Yeah, in the chat room, there's my time to live, 48, which means that I sent it out with one particular time to live, and I got back 48. I wonder what the time to live was that I was sending out. So let's find out more. Let's say we were getting some really big variability. Let's say that we were getting a lot of differences in here. So we want to really look at more data. So the next step would be perhaps a traceroute. And let's use the same address. To get to Google, in fact, you can see it is tracing a route to google.public-dns-a.google.com. Now, ICMP is a protocol that's used to manage devices through different hops along the way. If you're ever at a point where you're looking at traffic and your traceroute is not working, it's probably because ICMP is disabled. And that's not at all unusual to see that. Sometimes a traceroute won't work for you depending on where you are. A lot of people will filter ICMP. So if you're inside of a corporate network, you're inside of a student network, ICMP may be limited. You may not be able to use ICMP to communicate out. But in my particular case, I'm allowing ICMP, and thankfully, every device along the way is also allowing ICMP. Look at all the hops I have to go through to get to Google. I'm going to scroll down here in just a moment because there's a lot here to look at. I'm going to try to move my screen up a little bit so we can see this a little better. Let's see, how would I be able to really view all of this? Let's see if I can move it down some so we can view. So my traceroute to Google, my first hop was my local router, 10.1.10.1. That's the router. It's in the room. It's right here. If that was slow, wow, I'd have a problem. Notice the response time. Traceroute does 3 hops. 3 times it sends a packet, not 3 hops, but 3 packets, and gets all those packets and tells you for each one of those what was the response. Less than a millisecond. Good, because if it was more than a millisecond and it's next to me, we'd be in trouble. We'd know where a problem was. Probably some wiring or probably a problem with that router, but it wasn't. My next hop is to 68.35.220.1. That's the ISP's router. I sent it out to the ISP, off it went. And I got responses back. It's in the same city. I'm in Tallahassee. It's in the same city. I got these response times back. Not great response times, quite honestly. But for my ongoing knowledge, I know how that router is performing. I watch that router very closely. Believe me, I watch that router very closely. And so I know, well, those numbers, it's probably about right for that router. Then it hops through. Notice some of these have a DNS name that I was able to resolve. Some do not. And it just depends on if that provider has put a DNS name in its DNS for that device. It went to a router that is probably on a street called Timberlane Road. It went to another router, probably in that same building, because it looks like a 02 and a 01. Looks like they've got some odd naming conventions. It went to another router. Then it hopped up to Georgia, went up to Atlanta, went to Marietta. And then out of Marietta, it went to some IP addresses that do not have IP address names associated with them, 75, 149, 231, 86. Let me scroll down a little bit for you. Then it went to another router, then another router, then another router. And just before it got to Google, this hop, it timed out and finally got to Google. This is not unusual for Traceroute. This particular router, this particular IP address along the way is probably configured not to respond to ICMP. And so we tried 3 times and we went on to the next one. And finally got to Google. It's 13 hops away to get to Google. I have to go through 13 routers. If we had a routing problem, if we needed to understand the routing table, we would need to go to 13 routers from point A to point B to try to determine what route it's going. But look at the process it goes through. I'm all over the place. I don't even know where that Google device is. It's somewhere. I know I got as far as Marietta. I could probably do some lookups online to determine what the IP addresses were of these others. So on chat room, okay, somebody got 12 routes. You're closer to Google than I am on your 12 routes. Good for you. And that's why a lot of people who are in very large organizations and you have mission critical connections to the internet, you will very often want to find a provider that will get you as close as possible to the services or the people or the country or something that's going to give you the closest access. If you can reduce the number of routes, then you're reducing the complexity. You're bringing your devices closer to your users and hopefully provide a more efficient communication. So that becomes really, really useful in being able to make that happen. Now, in fact, okay, you had 4 request timeouts. So in the chat room, you've tried this Traceroute. You've gone out and seen how far. Your connections obviously are not going to go through Tallahassee. They may not even, after it goes to Atlanta, may not even go through these IP addresses. You may get a completely different list of IP addresses, except for probably the last one. And your last one may turn out to be a completely different machine behind the scenes. They're most likely, they're certainly doing load balancing behind the scenes, probably to different locations. So the 8.8.8 that I'm hitting may be different than the 8.8.8 that you're hitting, just to complicate things further, just to make things harder. But I guarantee you that you're certainly going to see a large difference in your IP addresses versus my IP addresses. Maybe once we hit these backbones that are here out on the internet, these high-speed backbones before we hit Google, those might sync up a little bit. You might see similar subnets associated with that. The trace routes you do today for yourself may look different than the trace route for tomorrow. So every day it may be different. Every route may be different. It's up to every provider along the way to make their determinations of how they're going to route this traffic, where it's going to go, and how they're going to make it work. So what we're looking for in this list, we're looking for some big problems. I'm looking for some major issues. And fortunately, I don't see any major issues with this. So not a huge, enormous problem associated with that. And if we were trying to troubleshoot this problem and really understand what was going on with it, that would be a very good way to do it. Now I'm gonna pull up one other view. I think I might be able to get this to show you a piece of this. I'm going to select a piece of my screen here. Maybe I am. Let's look at a window. One moment, please. I'm going to see if I can show you a piece of this. Let's see how this looks if I was to do this. So there's another command. This happens to be one that I downloaded. I'm using in Mac OS. This is outside the scope of the Network Plus exam, but it's an interesting command called MTR. And I find it's interesting because it gives me a full screen view. I'm going to get rid of my head here so you can really see this. Let me move this over. This is the same thing as a trace route, but it's on one screen and it's doing one after the other, after the other, after the other. Notice the same IP addresses, same routes. In some cases, it got multiple IP addresses to a particular route, but it's using one of those. So it's not only, yes, real time. Look at that. That's awesome. And I can see of the pings, the last speed, the average, the best, the worst, and for us statistics geeks out there, standard deviation of those. Isn't that great? That's a great trace route. This particular study group this month is brought to us by GTS Learning. These are the guys I work with. If you've ever seen their A+, their Network Plus study materials, my videos are integrated right into their technology. They have a technology called Freestyle. Freestyle is a technology. I think I've got this zoomed up on my screen. Freestyle is a method, a technology that they've set up. Let me move this so we can actually see the entire screen on this because I don't want you to miss this. Freestyle is a technology they've created that integrates the books that they have written on these materials. It integrates a testing environment. It integrates my videos all in the same environment. A lot of people ask me, where can I get the piece of a testing environment? Where can I really get questions that have been vetted? Where can I get information like a book that CompTIA says this is a good book to use? all of this can be found at GTS Learning. And I have a login to GTS Learning right here. And let's have a look at this. I'll pull this up and have you see it a little bit bigger. There we go. That's not the right one. That's the right one. So here's the GTS Learning site. I'm probably going to need to log in again. It's timed out already. I'm going to pull up the Network Plus information that they have here, and I'm going to log in. And once you get your login, there's a free trial for this. You can go in and try it yourself. The entire Network Plus book is here. You can go through the entire book, Unit 1, Module 1, Unit 4. You can go through everything, every module in this book. The entire course outline is big. This is the whole thing. This is exactly what you need to know for Network Plus. So very, very, very useful. Notice it's the N10005. In the chat room, somebody asked, what about N10004? That was the previous Network Plus exam. The latest Network Plus exam, the current Network Plus exam, the only one you can take right now, N10005. That's brand new. The N10004, unfortunately, was retired at the end of August. So you can no longer take the N10004. If you have N10004 content, it is not up to date. A lot of it, very similar. But if you go to the top of the N10005, I think I still have the video there that describes the differences between the two. And of course, there's a link there to take you to the objectives so you can tell what the differences are. Obviously, GTS Learning, way ahead of the curve here. They already have their 005 content already available for you. They also have, maybe you don't need a book. Maybe you already have a book. They have an exam you can take. Maybe you just want to buy the exam. You can do that too. You don't have to pay for the entire freestyle. You don't have to pay for seeing all of those things. You can simply go through the quiz and the practice exam. Now, what's nice about the practice exam is once you take it and you get it right, it tells you you got it right. But at the end, when you decide to hit the button and you got something wrong, unlike CompTIA's exam that just tells you, yeah, you got something wrong. Won't tell you what it was. You just got something wrong. This tells you exactly what you got wrong, tells you the question you got wrong, tells you the section of the CompTIA exam requirements it's associated with, and gives you a link to the section of the book and the videos that are associated with that problem. So not only is this a test, it also helps you understand what you missed so that you can then learn that material and do something else. I highly recommend you give them a shot. Go out to GTS Learning or go out to GTS Learning through professormesser.com/freestyle. That will take you right to the page. There is a sample right there, a free sample. You can try it out for yourself and see if that's something that may be useful for you. Very, very nice to have GTS Learning help us on our study groups. We appreciate all of their support. Every month you send me questions, not just about the Network Plus exam itself, but other questions that deal with aspects of the exam. So one of them was, what benefits will I get after being CompTIA Network Plus certified? This is obviously, if you're planning to take a certification, this is an important question. You are now spending time, in some cases months of your time, learning this new material, training on it, doing hands-on, watching videos, reading the books, going to study groups, trying to get as much information as possible. So at the end of it, you want to be sure it's worthwhile. Whenever people are looking at doing certifications, my question to them first is, what do you want to do with this? You can use certifications for many different purposes. Maybe you're looking to get a job. And if so, you want to find a certification that your employer's looking for. One of the first things I request people to do then is go out to monster.com, dice.com, whatever favorite site you like for finding those things, for finding the job listings that are out there, because the job listings will tell you, here's what your prerequisites are. Here's what we're looking for. So if you go and you see that this particular company is hiring and they're looking for somebody to maybe help with their corporate help desk or corporate repair center, and they say you need to have, we would like to see somebody who has a AA degree, a Bachelor of Science degree, a certification for A+, a certification from Microsoft, a certification of Network Plus. It will tell you right in the listing what they want. And it may be very worthwhile for you to look at many different types of jobs for that company to get a feel for what they like to have. That may be very useful to them. But notice it's not just the certification. They're looking for experience. They're looking for a degree. They're looking for different things. You want to have as many of those things as possible. So the main benefit you're going to get from being Network Plus certified is that you're going to have a leg up over anybody who isn't, as long as that's what you're doing with that position. Maybe you're now working on the help desk. You want to move into networking, and the networking guys have said, you need to have some basic understanding of networking. You should really get a certification, and we'll look at moving you into that department. Well, that's a good example of that. If you are looking at help desk and you look at a bunch of help desk listings, one of the things you'll notice is the help desk listing is sometimes showing you that it wants an A+. Sometimes it doesn't show that it's looking for a Network Plus. So you want to be sure to get the certification for the job you're interested in learning about. Don't get a Network Plus because you think it might be good. There needs to be a reason for getting it. So the benefit, of course, is that you'll have the certification. You'll have an amazing amount of knowledge. And I've said before, and I really mean this, is networking is the core of everything you will ever do in IT. If you are working in a data center, a strong knowledge of networking is incredibly powerful. If you're doing database management, a strong knowledge of networking is incredibly powerful. If you're doing security, if you're doing servers, anything, we're all touching the network. The more you know about the network, if you're a developer, the better your developer skills will be, the better your programming will be. If you're working with databases, the better your configuration of your database servers will be. You'll understand more of how to communicate onto the network. Should you have multiple ports on your database server? How would you configure those? Should they be on different networks? Should those two connections be synchronized together for load balancing? Unless you understand the networking piece, that's a huge hill to get over. So this goes beyond just the skills that you can put on a resume. These are skills that you can use to do whatever you'd like to do next. So I think Network Plus is a good example of doing something like that. Very, very nice. So the MTR I showed on my screen, if we want to back up a second, because it sounds like a few of you have tried this with the MTR piece. That was one that is compiled, a full screen view that's compiled for the Mac OS X was the one I was showing. It looks very similar to the one you would run in Linux is where I got that. So very useful to have that there. So if you bought an N10 004, should you stop reading it? Well, the content in there's a lot of overlap. The OSI model in 004 is the same OSI model as 005. No difference between those two. But there is a lot of information that is different on the 005 exam. There's more security, some other sections. So if you know the 004 content, make sure you look at the 005 materials. Make sure you understand what they're asking for and what's new. So very, very useful. What are the basics for becoming Network Plus certified? NF asks. And I know I do this on every study group, but I tell you, throughout the month between study groups, I get so many questions, probably at least one a day. I'm not exaggerating, where people will say, I've been studying for a couple of months now. Do I need to know about subnetting? How can you be studying for 2 months and have no idea what's on the exam? I think maybe people just don't know the exam requirements are out there. So I just want to make sure that you can go right to CompTIA's website. At the top of the index list of videos on ProfessorMesser.com for every CompTIA certification on my website, there's a link at the top to click here to get the certification requirements document. Takes you right to CompTIA. You put in your information, and they provide you with a detailed listing of everything you'll need to know. I mean detailed. They tell you exactly the OSI model, the TCP/IP model. They talk about what you should know as far as how these different devices relate to the OSI model. They take you through the entire thing. I use this as a checklist. Before I take my exam, I print this out on paper, dead trees. I never do that. I print it out because I can take that sheet of paper. I can start circling what I don't know, crossing through the things I do know. I can go through the entire list, and at the end of it, I can say, well, I know about 85% of this. I know 50% of this. I know almost all of it. And the things I don't know, I've circled, I can go study those. Once I know them, good enough that I think I can take the exam, I'll cross that section off. CompTIA stays pretty close to these requirements. So if you know that you're going to run into these things you don't know about. You've never even seen what's on the exam. Go download these exam requirements. Very, very, very useful to be able to do that. Make sure you understand what's going to be asked of you. That would be probably the most important thing I can tell you. And it all goes back to these exam requirements. Unlike other certificates that you might get, I'm looking at you, Microsoft. The CompTIA exam requirements are extremely detailed. The Microsoft exam requirements are anything but. But CompTIA did a great job. They tell you everything you need to know and they stick with it. So that's one good thing to keep in mind. And another question I got, this was from JL, asked, how do you keep motivated to study? Well, I drink my coffee and bang on the microphone right into my ears. The motivation to study can be overwhelming. I think this is my problem is I like to focus. When I get into something, I focus on it and I stay there an hour and then I'm done. I can't do this anymore. I'm out. And that may be the case with a lot of people. So don't get into a hole and cover yourself up for a month to try to cram all the information you need into this. And in fact, a lot of these things that we just did, if you go through the Traceroute we just did, if you look at the pings we just did, that was a very good practical example. That's what people do in the largest networks that you will run into, in these massive data centers for these massive banks. I've been in these. I've worked with these people that manage these networks, that some of the biggest companies you can think of, and even the smallest companies, the process we just went through to ping and to Traceroute works exactly the same. They do exactly the same thing every day. Their networks are, of course, much more complex. There's more routes, but the process is exactly the same. They're pinging, they're trace routing, they're looking at response times, they're running the MTRs. They're doing the same thing we're doing on our home network. Once you know it here, you're good. So a lot of the times, just doing it yourself makes the motivation a little bit easier because you get to a section on Traceroute, you get to a section on routing. You're like, I know this. I've already done Traceroutes. Oh, I'm good with that. A lot of the times I find when you're studying for a certification, a lot of the fear is the unknown. You really have no idea what you're about to get into. But what I find is once I go through it, once I learn it, once I do the hands-on, I'm like, that was it. That was ping. That wasn't so hard. I thought that was going to be some monster thing. Routing tables? I thought routing tables were going to be hard. We just stepped through one. That wasn't so bad at all. So really, once you dive into it and you become comfortable with the materials, it really is quite useful. It keeps you motivated because you've learned something. And for me, that's what I like the most. When I started doing a lot of these videos, they're asking things I don't run into a lot. Like, let me read up on that. I'd like to learn more about configuring my network with that particular link or that particular routing protocol. I want to know more about how to do that, and I'll read up on it. I have to pass these certifications too. Wouldn't be any good if I did a certification program that I didn't pass myself. Or perhaps it would be good. It would tell me this wasn't very good. But in this case, it all worked out all right. So that's how I keep motivated. I like to learn. So if you like to learn, you'll probably stay motivated as well. And if that doesn't work, there's always coffee. Let's look at our link of the moment. This is another question I get all the time. All the time. And I found this interesting website. There are a lot of websites that do this, but I found one that I really liked. And I thought I'd show you. This is from the networking forum, networking-forum.com. And I made a bit.ly link because it's a pretty long link. The bit.ly link is bit.ly/practice subnetting, all one word. You know what? I didn't bring one up on my screen, so let's do that. Practice subnetting. And that will take you to the site that is networkingforum.com. You should be able to see this. Let's zoom up a little bit so you can really see it. What they do is give you some subnetting questions, just randomized subnetting questions. This is really great. So if you're really trying to get subnetting down, this is a good way to do it. Just give me a random subnetting question. So the subnetting question here is, what is the subnet and broadcast IPs for host 10.246.32.162/16? And you can work on the answer, try to figure it out. And then if you think you know the answer, you can click the button that says reveal the answer. Well, the subnet address 10.246.0.0, the broadcast IP address 10.246.255.255. Okay, that was a pretty good one. But What if you're trying to figure out, well, how'd you figure that out? I don't know how they got that. What was that about? There's a link right here that says reveal the work. And it takes you through the binary mathematical process, the same process that's in my videos, that takes you through the entire step 1, step 2, step 3, step 4, takes you through the whole thing for every single question that's in here. Let's do another one. Okay, click for a new random question. New random question. What are the subnet and broadcast IPs for host 10.63.169.141/27? I'm just going to go to reveal the work. Here's the work. Here's the process you go through. That's fantastic. Completely random. Just do it all the time. You can sit there all day and do subnetting questions. Now, to this point, I'm showing you this really nice site from networking-forum.com. It's the holidays, October. They even have a little jack-o'-lantern in their logo now. But one thing to keep in mind is that the subnetting section of the Network Plus exam is very, very small, very tiny, very little. You might get a subnetting question. You might get 1. You might get 2. I can't imagine you get more than that. So if you're the kind of person who's gone through this, you've spent weeks trying to learn subnetting, you're not getting anywhere, you can't understand what's going on, you're frustrated with the whole process, just skip it. Go learn something else that you can get right on the exam. Because ultimately, let's say you don't learn subnetting at all, you miss 2 questions. And the time you spent learning new things rather than subnetting is going to offset those 2 questions. See what I mean? You have to think about how much you want to do this. Now, in my mind, subnetting is not so crazy. It's not that bad. You'll be all right. Don't worry. Subnetting is not going to, it's not as hard as it seems. Again, it seems, I'm afraid, it seems hard. But once you start getting into it, you do this over and over and over again, it's not so hard. You learn those 5 steps to go through this process, not so hard. So when you get into this, you start working with it, you'll see it's not as hard as I thought it was. And you do a few of these random questions on the networking-forum.com. That comes in handy as well. So don't kill yourself over it. But if you're looking for a place to get some really good questions, some samples, some things where you can just shotgun through these subnetting questions, that's a really great site to use. And I've got it set up on bit.ly/practice subnetting. We are into 18 minutes. I appreciate everybody hanging out today. After we finish today, we're going to be going through some extra questions. There's an extra set of things I've got on my list here. I'm going to go through some of these Network Plus questions I got and sort of post, because I know not everybody can hang out all this time. But I did want to, before I close the formal study group, I want to let you know that you can follow what we're doing at Professor Messer, professormesser.com/Twitter. You can find me also at Google Plus at professormesser.com/Google Plus. There's YouTube as well. And although it's not as great as it could be because they don't always show you what I post there, you can also at least manually go and look at what's going on at professormesser.com/Facebook. Just don't expect to be guaranteed to see everything I post there in your stream, because Facebook doesn't work that way. I want to also thank GTS Learning. They've been great for supporting what we're doing here, and it also supports me if you visit them at professormesser.com/freestyle. And you can see all of their offerings from somebody who is a certified provider of CompTIA materials. And they have great stuff. And of course, thanks to you, we couldn't do this every month unless we got your questions. We were able to go through and look at the information you have. You give me questions in the chat all the time. If you want to follow us during the time where we're not doing a study group, I'm always in that chat, it seems, at the bottom of the page on professormesser.com. And if I'm not there, plenty of people are there to help answer your questions. Make sure you take advantage of that as well. Well, that brings us to the end of this study group. Thanks again for attending. We'll see you next month on the Professor Messer Network Plus study group.